Hello, my name is Zahra Mohammad Nejad. I hold a master degree in information technology and have been working and researching in this field for last 10 years. My partner in this project is Mr. Mahdi Ahmadian, who is graduated in information and communication technology. We have been working on this project for 2 years, which we call it IGSense. I will generally describe this system in next slide.
Intelligent plant growth system is an automatic system to control plant growth process. It can be used in big or small size of farms, garden, greenhouses, indoor and outdoor green walls, and vertical farms. It means we can use this system in any place and any weather conditions and any scales. The main problem in existing system is the lack of modularity of the systems, which may make it necessary to purchase a complex system to upgrade the system and designing the whole system on one board in case the possibility of failure, circuit complexity, and the impossibility of expansion. Existing systems are limited in increasing the number of soil valves, which prevent the possibility of expanding the irrigation space, and it's not possible to offer different programs depending on the type of plant, and the number and the type of sensors are limited. Existing systems operate only on the GSM platform, in which case there is no alternative if GSM is disconnected, and current system is not able to save incoming reports and comments. For this purpose, a comprehensive and intelligent system has been designed to solve all the problems of the current system. Among the capability of the system, the following can be mentioned: separating main board, controller, and sensor board from each other and modulating them, which solves the problem of limiting the definition of the device. Elements such as solenoid valves, pumps, flow switch, and sensors. The possibility of increasing the number of solenoid valves will make it possible to define intelligent programs based on the information received from the sensors and adjust the solenoid valves. Ability to increase the number of sensors per pump and solenoid valves to provide a different application based on different plans. Use GSM, GPRS, and internet platform as a backup. Establish communication between the mentioned board wirelessly. The possibility of direct connection of the device to the internet to receive the program, send reports, set orders, and receive reports through a server, in which case the information sent and received can be stored in server. The system consists of 3 boards: main board, controller board, and a sensor board, also a server and an application or software. Main board is the central unit of the system, which consists of several modules such as Wi-Fi module, LAN module, SMS module, Bluetooth module, display module, and so on. Controller board consists of a flow switch controller, a solenoid valve controller, and a pump controller. Sensor board is responsible for monitoring and calculating the conditions of surrounding environment and plant. It consists of these sensors: soil moisture sensor, ambient temperature sensor, ambient humidity sensor, soil pH sensor, light sensor, and ultrasonic sensor. Based on main board processor, the number of controller board and sensor board can be increased. Server is a connector between application and mainboard. It can stream firmware updates the boards, save system function and information, generate reports based on the system functions. Application or software is a mobile software to connect plants, monitor system conditions such as solenoid valves, fertilizer tank, flow switch, soil moisture, ambient temperature, light sensor, and ambient humidity. Once the system is up and running, irrigation programs are downloaded from the server through the mainboard connection. For irrigation, the sensors capture environmental data including temperature, air, humidity, soil moisture, and soil pH. The mainboard processes the collected data and selects an appropriate program depending on the established parameters, including plant kind, ambient temperature, soil moisture and humidity, and soil pH. Depending on the program, the controller board receives the appropriate instructions about the state of solenoid valves and pumps. It calculates which solenoid valves to open and when, for how long, and which pumps to use to provide fertilizers to irrigation for which plant. The flow switch sensor begins by determining the state of the water within the pipes. If the water is presented in the pipes, the valve or solenoid valves begin to irrigate. Then halt and pumps add the quantity of fertilizer to other additives to the solenoid valve's water. And finally, we set up a lab environment and compare our device to an existing device. Competitive parameters are plant growth rate, water consumption, connection ways, number of sensors, expanding or modularity, light consumption, and backup capability. As you can see the results in compare chart, IGSense is more efficient than sample device. Thanks to the honorable judges for their kind attention.